Hi guys, got a request today from a student who is on the field trip and missed this day to talk about factors a little bit. So this is that. Try to make this video kind of quick but still hit the basics. Big thing to know about factors is it's a vocabulary word. Like, it's important, it means something. A factor is something that you multiply to get something else. Typically, like, there are two factors that will make a product. These are the academic terms we've used before for math answers to multiplication problems. Factors are always, always, always referring to multiplication, and they're always, always, always referring to the smaller thing. Shouldn't say smaller necessarily, but these things that multiply together to make a product. So if my product is 15, the factors could be 3 and 5, because 3 times 5 is 15. But they could also be 1 times 15, right? So there's a lot of different things. I'm not going to get into the weeds of saying, well, what about 5 and 3 and 15 and 1? Like, that's not our purpose today. These are the four numbers that would be factors of 15. So without going too far, I want to talk prime versus composite. That came up on Tuesday also, that some numbers are prime, others are composite. Every number is like one or the other. And I'm not going to get into one in the debates about the philosophy of one here. We're going to start off with two, and I want to demonstrate. And I also want you to say prime is special, composite, not really. Composites aren't really special. And the reason primes are special is because if I take the number 2, which is to me like the smallest prime we're going to use, it is the only way to multiply to make it. The only factor pair of this is 1 times 2, right? 1 and 2. There's no other way to multiply to make 2. And then I think about the next number, 3. Same thing. There's no way to multiply to make 3 except 1 times 3. And the next number counting up is 4. But before I call 4 a prime, even though it's really small, 4 has 2 ways to multiply it. We've got 1 times 4, obviously, but also 2 times 2. When you see composite, I want you to think of like a composition, and that's when you put something together, or it's composed of many pieces or something like that. So 4 has multiple ways to make it, but 2 and 3 only have one way to make it using multiplication. So the next number is 5. 5. There's only one way to multiply to make it. 1 times 5. 6. Back to composite. Some of you notice really quickly that, like, if it's even after 2, all evens are going to be composite because they can all be multiplied. Something times 2 will give you that number. They can all be divided by 2, right? Don't forget that, like, 36 divided by 2 equals something is the same as 2 times that something equaling 36. Okay, that kind of ties in here. The biggest composites that people mess up, 9 and 15. Okay, 15 we just showed you why it's a composite, not a prime. But 9 people consistently forget. Yeah, even though it's so small, because our other primes are like 2, 3, 5, 7, 11. You can see right after 2, every other one of them is odd, but it's not every odd. 9 is not a prime. It's composite because there's 1 times 9 and 3 times 3. So we'll be asking you to, we'll give you a number and we're going to ask you if it's prime or composite. Okay? Next, perfect squares. Really briefly, that's going to come into play. Perfect square is a fancy way of asking you, is this a number times itself? So we have very few of these that we're going to use on a daily basis. But really the idea is, what is 1 squared? Okay, that's where this comes from, square. Well, that's 1 because it's 1 times 1. What is 2 squared or 3 squared or 4 squared? Okay. These are, it's 4, this is 9, and this is 16. So I might ask you, hey, is 16 a perfect square? You would say, yeah, because it's a number times itself. It is 4 times 4. It's something that was squared. If I ask you 25, is that a perfect square? Well, yeah, that'd be 5 times itself. Okay? But if I ask you something different, usually the best way to do it is just figure out the squares around something. And I could say, oh, is 18, well, that's on the homework tonight, is 20 a perfect square? No, because we're not going to consider 4.2 something or other. We're going to say 4 times 4 is 16, 5 times 5 is 25. There's no number here, no whole number that I can multiply by itself to get 20, okay? To keep these videos short, I'm going to stop here to just say these are prime composite and perfect square. I'm going to do another video in a little while once the opportunity presents itself tonight about the actual factoring methods, okay?